Hey guys, so I've been getting a lot of requests for another video about the combined gas law. So here we go. So the combined gas law is P1 times V1 divided by T1 is equal to P2 times V2 divided by T2. Basically it says there's a relationship between the starting pressure and volume and temperature related to the ending pressure, volume, and temperature. So the combined gas law combines three different gas laws that we've already talked about. Boyle's law, which relates to pressure and volume. That's the top part. Charles's law, which is volume and temperature. And then Gay-Lussac's law, which is pressure and temperature. So whenever we're looking at the combined gas law, basically it's solved the same way as Charles and Gay-Lussac's law, except for you have one extra variable thrown in. So let's take a look at some problems related to the combined gas law. Okay, so let's say that a toy balloon has an internal pressure of 1.05 atmospheres. And a volume of 5 liters. Okay, if the temperature where the balloon is released is 200 Celsius, what will the new volume be when the balloon rises to an altitude where the pressure is 0.65 atmospheres and the temperature is minus 150 Celsius? So I'm just going to abbreviate that. What is the new volume if P equals 0.65 atmospheres and T equals minus 150 degrees Celsius? Okay, so let's look and see how this would be solved. This is number 4 on your combined gas law worksheet, if you were paying attention. Okay, so let's find all of our important information. A toy balloon has a pressure of 1.05 atmospheres. So P1 is 1.05 atmospheres. And a volume of 5 liters. So V1 equals 5.0 liters. If the temperature where the balloon is released is 200 degrees Celsius, T1 is 200 degrees Celsius. We know it needs to be in Kelvin, so let's just go ahead and add 273 to that. Make that 473 Kelvin. Okay. What is the new volume? I'm looking for volume. If the pressure is 0.65 atmospheres and the temperature is minus 150 Celsius. Again, we need to change it to Kelvin. So that would be 123 Kelvin. Okay. So the first step in any of these problems is to identify your variables. Once we've done that, we can plug into the equation and solve. Okay, so I'm just going to plug into this equation right here. P1 is 1.05 times V1 is 5.0. T1, we're going to use the Kelvin value, is 473. Is equal to P2 is 0.65 times V2 is what I'm looking for, so I'm just going to leave it as V2. T2 is 123. Again, we're using the Kelvin value. Okay, that is step 2. Plug in your variables. Okay, so I've identified the variables from the problem. I've plugged them in. Now it's time to rearrange and solve for V2. So I'm going to use the butterfly or cross multiplication method. I'm gonna get rid of some of this to create a little bit more space. Okay, so I have 0.65 times V2 times 473. All that is equal to 1.05 times 5 times 123. Okay, this is all one big equation. I just ran out of room. All right, so let's simplify. 0.65 times 473 is 307.45. So 307.45 V2 is equal to 1.05 times 5.0 times 123 is equal to 645.75. From here, I have a number times my unknown equals a number. So I'm going to divide by 307.45 on both sides. So that V2 is equal to 645.75 divided by 307.45. And you should get about 2.1 liters, because my unit for volume is going to be in liters. Okay, so there is the first problem using the combined gas law. So we were solving for our V2, our unknown volume variable. Okay, let's look at another problem. Okay, so let's say that a hot air balloon at ground level pressure, 1 atmosphere, has a starting volume of 100 liters at 297 Kelvin. What would the temperature need to be in order to increase the volume to 1,000 liters at a pressure of 3.5 atmospheres? So let's write down what we know. Okay, so I'm going to start out P1, V1, and T1, and P2, V2, and T2. Okay, so it tells me a hot air balloon at ground level pressure 1 atmosphere. My starting pressure is 1 atmosphere. Has a starting volume of 100 liters. How convenient, it even tells me it's the starting one at 297 Kelvin. Your starting values are always your ones. What would the temperature need to be? So it's asking for temperature in order to increase the volume to 1,000 liters. There's a key phrase right there, increase the volume to. That means we're changing it, which means that that's going to be our changed value, or 2. All right, so 1,000 liters at a pressure of 3.5 atmospheres. Okay, I've identified my variables. Let's plug them in. Okay. So, I know that P1 times V1 over T1 is equal to P2 times V2 over T2. So I'm going to plug into that equation. It's the same one from the previous board. So P1 is 1 atmosphere times V1 is 100. T1 is 297. Is equal to P2 is 3.5. V2 is 1,000. T2 is what we're solving for. Okay, so I've plugged in my variables, and now I'm going to try to solve. So again, I'm going to use the butterfly or cross multiplication method. Right, so let's look and see. I have 1 times 100 times T2. Is equal to 297 times 3.5 times 1,000. All right, let's simplify. So 1 times 100 is just 100. So 100 times T2 is equal to 297 times 3.5 times 1,000. Is 1039500. All right. So it's 1,039,500. All right, we want to get T2 by itself, so we're going to divide both sides by 100 to get rid of that. Which just gets rid of those 2 zeros right there. So my T2 value is 10,395 Kelvin. Okay, so bring it a little bit closer. Okay, so basically it's the same as solving for the Charles law or Gay-Lussac's or Avogadro's laws. The only difference is I'm adding in one extra variable on the top so that you're going to have to simplify. That is really the only difference. You're still cross multiplying. You're still solving for your unknown. So I hope that helps, and let me know if it doesn't.